far in topic 2, we have had equations that have answers to them. But in this lesson, we're going to learn that sometimes equations don't have any answers. Other times, they have one answer, like all of the problems we've done. And another situation is where any possible number that you plug in works. So we say that has infinitely many solutions. So your learning target is to be able to identify the number of solutions an equation has. The solution to an equation is the value of the variable that makes the equation true. And like I just said, sometimes there's no value you could plug into an equation that would work. When this happens, we say there is no solution. The problems that we've done so far have one solution. That means only one number can be plugged in to make the equation true. And in this last box, sometimes there are equations that will work no matter what value you plug in for the variable. These are called identities, and we say there are infinitely many solutions. If you wanted to, you can put this symbol for no solution. When you have one solution, you're going to have x equals and then whatever the answer is. And when you have infinitely many solutions, you actually write down those words, infinitely many solutions. And that could end up to be x equals x, or 5 equals 5, or several other things. -2 equals -2. Anything that ends in a true statement would be infinitely many solutions. So let's see some examples down here. When we go through our steps to solve equations, we are going to combine like terms and use the distributive property when necessary. So here I see I can use the distributive property, 5 times 4x, and then we're going to change that to be plus a -10. So that's 5 times -10. So over here I have 5 times 4x plus 5 times -10. So that ends up to be 20x plus -50. On the other side, we are going to combine like terms. 8x plus 12x is equal to 20x minus 10. So I'm just going to write that down here so it's on the same level. Alright, and then to get the variables on the same side, I would subtract 20x from both sides. And here I notice that something weird happens. 20x minus 20x cancels on both sides. So this drops down to be -10, and this drops down to be -50. So we have -10 equals -50, which is not true. So if we have a false statement at the end, we would say there is no solution. Let's take a look at this one. So with this one, I'm going to use the distributive property, 3 times 3x and 3 times 2. I'm going to do that mentally, so 3 times 3x is 9x, and 3 times 2 is 6, and then I'm going to copy down the plus 41. On the other side, I'm going to combine like terms, so I have 14x, and then remember we look at the sign in front, minus 5x. So 14x minus 5x is 9x. And then we have plus 3 plus 44. So that would be plus 47. Going back over to this side, we have plus 6 plus 41. So that gives me the 9x that I had plus 47 equals 9x plus 47. So if I subtract the 9x from both sides, I notice something weird happens again. 9x minus 9x cancels, and I'm left with 47. 9x minus 9x cancels over here, and I'm left with 47. This time, though, I'm left with a true statement. 47 is always equal to 47. So when we are left with a true statement, there are infinitely many solutions, and that's what you would write for your answer. Infinitely many solutions. And you can abbreviate solution like that. So make sure you realize this is what you would write for your answer. Let's take a look at some more examples. The first thing I notice when I look at number 3 is the minus sign, so I'm going to be doing that every time I see a minus sign. That's adding the opposite. That's what subtraction is. So then I notice on the right-hand side that I can use the distributive property. 6 times 2x is 12x, plus 6 times negative 7 is negative 42. On the right-hand side, I have like terms. 3x plus 5x is 8x. So I have 8x plus negative 53. So in this problem, I have variables on both sides. So I'm going to take away 12x from both sides to get the x's on the same side. So that leaves me with negative 4x plus negative 53, because that drops down. These cancel, so the negative 42 drops down as well. Now I add 53 to both sides to get rid of the negative 53. So the negative 4x drops down. These cancel. And over here, I'm left with positive 11. Then divide both sides by negative 4, and x equals 11 divided by negative 4, which is negative 2.75. So that's my solution, and this means that there is only one solution. I got x equals a number, so that means there's one solution. Alright, let's take a look at another example. Here, I'm going to change the minus signs to be plus and negative, and that usually helps students get the right answers. So I'm going to look at combining like terms on this side. 6x plus 3x gives me 9x, and then I change that to plus a negative 1. So that's what's on the left-hand side. On the right-hand side, I'm going to distribute the 3, so I get 3 times 3x, that's 9x. And then I'm going to do 3 times negative 10, so that's plus negative 30. And if I subtract 9x to get it to the other side, something weird happens where the 9x's cancel on both sides, so I'm left with negative 1 is equal to negative 30. And that is a false statement. Negative 1 does not equal negative 30, so that means there are no solutions. Let's take a look at the big idea now. Notice that 2 of our answers were no solution, and both of those ended up in false statements at the end. So when you solve equations and the variables cancel on both sides and you're left with a false statement, there is no solution. And we saw one example where there were infinitely many solutions. The variables canceled out, but we were left with something that was true. So, when they cancel out and you're left with a true statement, there are infinitely many solutions. Now, hopefully some of you looked at this work here and said I did too much that was not needed. So if you take a look way back here at this part of the equation, 9x plus 47 equals 9x plus 47. That should make sense to you that that will always be true because the same exact thing was on both sides. So when you have the same thing on both sides of the equation, then there are an infinite number of answers. It will always be true. However, when you look up here at this one, 20x minus 10 equals 20x plus negative 50, we could have stopped there. We have the same coefficients of 20, but different constants, negative 10 and negative 50. That will never ever work. So again, if you look down here, we have 9x plus negative 1 equals 9x plus negative 30. The coefficients were the same, but the constants without the variable were different. When that happens, there is no solution. You are going to be asked to solve the problems on the back side and tell if there are no solutions, one solution, or infinitely many. And when there's one solution, go ahead and give what the solution is. Good luck.